Great, thank you and welcome. It's exciting to be here with you guys, and especially with this panel, which is fantastic to break down a little bit about advanced air mobility, as Don was just mentioning. Before we dive into some of the complexities about advanced air mobility, how it's being adopted, how we're building the future with advanced air mobility, let me first give a chance for our panelists to introduce themselves so you have a sense of who's going to be breaking this down for you. So maybe Scott, we'll start on the far side and work our way down.
Thank you, Joel. My name is Scott Stoffen. I'm the Senior Manager for Grassroots Advocacy and Chapters at AUVSI. I'm an attorney myself and a Part 107 drone pilot, so I work very closely on our state and local advocacy work. We have more than 30 chapters across the nation, and we do a lot of engagement speaking with local lawmakers, helping them understand what are some of the benefits that drones can provide, what are sort of good pieces of legislation, what are bad pieces of legislation, and I wouldn't be able to do that work without our chapter leaders and without our team in DC at AUVSI HQ. So it's been a really great chance to speak about these issues, work on public acceptance, work on public education. Thanks.
Good morning. I'm Darshan Divakar. I go by Dash, the head of airspace innovation and partnerships for AFWERX. And within AFWERX, the Prime division, which most of you may be knowing, the Agility Prime program is one of the Prime programs. Our focus is to help solve the problems which focus on commercial viability. We want to help companies that have the right technology get the support, not through just funding, but also working with the regulatory decision makers on what is needed and how we can solve it. The Airspace Innovation Team has been tasked by AFWERX and the US Air Force to look into areas that are going to be a challenge when it comes to integrating eVTOLs. And at the same time, what else should we be looking at through partnerships? That way we don't have to start from scratch. So that's the area that I'm working with my team. And I'm also the president of AUVSI in North Carolina.
Hi, everybody. My name is Tony Drummond. I am the president of Titan Aviation Global. Titan is a general aviation company that has aircraft managed all over the country, all over the world, actually. And I'm also working in consulting for Vertiport and some drone projects as well. So have my hands in a lot of different pots. Excited to chat about what we're up to today.
Hi, I'm Don Birchoff from True Weather Solutions. Thought I kicked my coffee there. We're a weather data analytics company focused on the drone air taxi business, especially on low altitude weather, which is going to be very impactful for battery operated vehicles due to winds and other challenges. Today, about 30% of all crewed aircraft that are canceled or delayed due to weather could fly, but they don't because we don't have good weather systems. When we talk about eVTOLs and BVLOS drones, it's going to be a much higher attrit rate, and much of that attrit needs to be dealt with by adding better sensor capabilities, not just at vertiports or on the ground. We need data coming off of LiDARs on towers and other things to really get an MRI of the atmosphere. I'm working with ASTM as the lead to rework the weather standard. I'm working closely with the FAA, and so my role here is to get as much flight time as possible when weather conditions are tolerant.
Great, and thank you. And I'm Joel Roberson. I'm a partner at Holland & Knight, which is a law firm. I'm located in Washington, D.C., and my practice focuses on representing clients at the intersection of transportation and technology. So working on drones, advanced air mobility, but also automation across all modes of transportation. So we're really excited to talk about this topic because there's so much happening in the advanced air mobility space, as we'll break down. Many believe that right now the world is in its third revolution in aviation. The first revolution was our ability to prove that powered flight could happen, starting with the Wright brothers and heading forward. The second revolution was the jet engine, right? That transformed our world, allowed us to get from point A to point B in much more accessible fashion. The revolution we're going through today, which involves things like new aircraft design, electrification, hydrogen propulsion, and also automation, is being considered today to be the third revolution. But as we think about, one of the key questions here, and this is framed as if we build it, will they come, is who's going to dominate that industry? Is it going to happen in the United States where the first two revolutions happened, or is it going to happen in other parts of the world? But before we kind of dive into that, I just wanted to break down what is advanced air mobility. And some of you may be steeped in that, but just to make sure we're all operating from the same foundation. In 2002, Congress enacted legislation called the Advanced Air Mobility Coordination and Leadership Act. For those of you that are unfamiliar with that legislation, it required the administration, the executive branch, to establish an interagency working group to work on all of the challenges that advanced air mobility presented to our country. Right now, that's being implemented. There's 20 different executive branch agencies that have come together and convened, and they've identified 5 priorities that they're working on across the entire whole of government approach to ensure that the country is ready for advanced air mobility. But in that legislation, the importance of bringing it up at the front end is there was the first federal definition incorporated into law of what is advanced air mobility. And so I'll just read it for you so that you all have that foundation. So the term advanced air mobility, or AAM, means a transportation system that transport people and property by air between 2 points in the United States using aircraft with advanced technologies, including electric aircraft or electric vertical takeoff and landing aircraft in both controlled and uncontrolled airspace. So it's a fairly broad definition. It's one that's going to need to evolve over time. It's very electric centric. And certainly as we prove that hydrogen can be used and other advanced propulsion technologies, that definition will need to change. But within that framework, that's where we're operating today. So as we think about advanced air mobility and its commercial and military applications, let's just start. Scott, maybe you can help us kick this off. Could you tell us a little bit about what the commercial AAM industry looks like and where it's at this point?
Sure. Happy to do that. And like many things regarding drones and advanced aviation, there's a ton of acronyms and they get interchanged and people misunderstand what they mean. I think we did a good job starting off with what AAM is as advanced air mobility. That's sort of the overarching concept of what these new aircraft are going to bring to traditional and advanced aviation. We also have the terminology around urban air mobility, or UAM. So this is more city-centric, higher population density, higher air traffic. These are things that you would normally think of as air taxis, what you've seen through Uber and the likes of that over the last 5 or so years on, being able to take people and property from point to point, usually in an urban environment. You live in the suburbs and you want to get to the city center, you live in the city center and you want to get to the airport, that kind of transportation that's happening. There's also the concept of regional air mobility, or RAM. So these are things where you might be going from city to city, kind of shorter hop, regional air jet type pathways that you would be using. But instead of taking a jet in your existing plane, you're taking these aircraft that have that more sort of distributed electric propulsion in whichever flavor that particular aircraft has built into it. We have a number of companies that are based both here in the United States and around the world that are going through the process right now of testing and proving out that these novel designs actually make sense, are safe, are going to be viable economically and viable for actually meeting the need of the markets. A lot of them are trying to understand, so how many passengers could we serve? What distance could we safely operate in when working from distribution center to distribution center? How does that affect traffic on the ground? If we're taking trucks off of the roads, how do we consider that in the operational cadence and the operational side that we're doing? I'm looking over here. I see Geo and what they're doing at Huma Terrebonne Airport in Louisiana. They're also looking out over our Gulf coastal waters. We have a lot of oil and gas assets off platforms that regularly are ferrying people and products and materials using traditional helicopters or using boats to get out there. So what do those rules look like in our NAS? Where does the FAA sort of power exist, or where does it wane off? How do we deal with enabling more testing and more operations, getting beyond the pathway that we have? I've been lucky enough to see multiples of these aircrafts operating in their testing phases, getting out to Joby in Marina and seeing their testing facility, getting out and seeing Archer. And, these are huge aircraft. There's no one on board at the time. They have a whole team of people on the ground with, communication links, with video links. They're watching airspace. They have chase aircraft. So how do we get from that perspective of these aircraft are novel and they're interesting and they're exciting? How do we get people feeling like they're going to be safe? They're going to be part of the commercial discussion when it comes to aviation. I know that Dash and his team are doing a lot of good things to enable the military side. He probably has even more acronyms than what I've run through here, but I'll let him kind of discuss that side of it.
Yeah, when you think about, thanks, Scott. When you think about these advanced air mobility platforms, much like a Tesla or an electric vehicle on the ground, they're much quieter than a combustion fuel engine. So when you think about military applications, there's some pretty obvious benefits. You can have a vehicle that's potentially silent. You also have supply chains where getting jet fuel around the country to conflict regions is challenging. But Dash, could you break down a little bit more about what the DoD views as the opportunities with AAM?
Sure. And so, let me answer first. Most of the people have this question is, why is the Air Force interested in this, or why is the DoD investing so much time and money into it? So the question comes back to one of the problems that we faced on the small drone side. That is, our startup companies couldn't keep up with the Chinese technologies. And as a result, the market size was too small for our startup companies, and at that time DoD did not invest or did not look at it like the way they're looking at now, and feel that small drones could be a useful technology. Even today, bases are not using small drones on a routine basis. They still have the struggle of integrating small, SUS into bases. But then it comes back as we also have to think about the future. And the example is also from the space side of things, investing in SpaceX and stuff. Government has seen an interest in investing in startups. And in 2020, when Colonel Nathan Diller was tasked to lead the Agility Prime program, which is under AFWERX now, the focus was how do we help our startup companies get the first the funding part of it, but access to government facilities where they can do testing. Aircraft certification, a key challenge, which the FAA is also facing, where we can help out. When these aircrafts fly in military airspaces, we can give them military airworthiness certification, military flight release to fly in a military airspace. Now, this helps them to work with FAA to understand what are the needs on the commercial certification side. And then even from our perspective, we are working with FAA to understand what are the challenges when it comes to certification. Each aircraft is different, each company is different, each company's level of understanding of certification process is also different. So why not two agencies come together and figure out this process? So we have a strategic MOU with FAA, our AirCert office, where we are working to see the synergy where we can help out, and then the FAA can take over after a certain point, especially those companies that are mature enough who have a technology today. So we are looking at both sides, the future technologies, which are idea to prototype, but also which are actually flying. Because maybe the military use cases won't be this current iterations of aircrafts. It could be the next iteration, because there's a lot to learn from these aircrafts. But at the same time, that doesn't mean that these companies don't need help. So we have the Agility Prime program. We already put in, I would say, over $7 to $8 billion towards AM, and it keeps going. And most recently, you must have read the news of Joby aircrafts. We are going to be acquiring 9 aircrafts that we're going to be flying at Edwards. These are where the transition phase starts, because till now we were dependent on the companies, on the testing, on basically on the overall aspects. We had to wait on the company's timeline to do those efforts. But now with having our aircrafts at our base, we can push it further, we can speed up the process. So these are things that from a military standpoint, but also when it comes back to the point is, are we just doing this for commercial? There's been in the last couple of months, people have also asked this question is DoD only interested in the commercial side of things? No, this is also from a military use case side of things. So March of this year, General Brown announced the Air Force's operating concepts, the future operating concepts, in which there are a number of points like air superiority, global air mobility, it's global mobility, air mobility, global strike, I'm trying to remember without notes. So rapid global mobility, ISR and C2. Yeah, perfect. I got all 5 of them. So each of these areas fall into technologies like AM, but also other technologies in the focus of autonomy and AI. So there's a lot we are looking at. From these companies, we are getting to learn something that we didn't know before. And every company, we have a set of program managers, engineers working with them to help them also solve their problems. Because as these companies already have physical aircrafts built, they're also taking our guidance because we have access. They have access to our SMEs on the future versions of these aircraft. So the commercial viability is a key part here, because when these companies have commercial viability, we can identify military use cases after that. So that's a dual use technology focus. And now we have also started talking about dual airspace focus, because these companies, the technologies that we buy from these companies shouldn't be limited to just flying in military airspace, but should be able to fly in civil airspace also. So everything we are doing here is to ensure dual use technology and dual use airspace can be accessible to both sides.
Perfect. So there's a clear commercial opportunity for advanced air mobility, a clear Department of Defense interest. Then there's a global competition issue. So there's a lot of demand going in, a lot of resources, a lot of investment from investors to support the advanced air mobility. But this panel was named intentionally, if we build it, will they come? And the question is, what about the infrastructure, right? We're very focused on making sure we get a first-in-class, safest aircraft to market, but where's it going to take off and land? So, Tony, could you talk a little bit about infrastructure needs and kind of where we're at in understanding what infrastructure is necessary for AM?
Sure. So I'm working on ground infrastructure right now with a company called Volatus Infrastructure, where I'm consulting for that company through Titan Aviation. And really what we're finding right now is we're starting at GA airports, general aviation airports. I'm a general aviation expert. I've worked in this field my whole life, so it's very comfortable to understand what the needs are. Really what we're finding right now is we have a lot of airports coming to us basically telling us that they're interested. They want to get involved in what's going on in AAM. And in order to do that right now, I'm going to go back to something that Scott brought up, which was the different types of air mobility. Right now, we're really focusing not on UAM, which is intra the city. We're working on RAM, which is regional air mobility. So the airports are wanting to electrify, and that's different than a vertiport. I want to be clear about that. Electrifying a current airport is going under regulations that the FAA sets, a little bit loose at this point, but we can put up charging stations within that framework that can charge an aircraft that is not an electric vertical takeoff and land off. It's just regular short takeoff or standard takeoff. They're just going to kind of taxi, and they have a hybrid electricity system on board, charge up and go. So we have a lot of that happening right now, where companies are coming saying we want to electrify. The second part of that is the actual vertiport. We have OEMs we're working with that are starting in certain cities that are looking to maybe take 4 airports from one location and 4 airports from another location and connect them. So in order to do that, we've been tasked by the FAA to use the current infrastructure that's already there and adapt it. We're not building anything new right this second. Obviously, we're working on airspace, but coming from a ground perspective, we're using our current regulatory framework and adapting it to, say, build vertiports, if you will. And so, what we're finding right now is a lot of the airports are coming to us and saying, we want to get started. We want to be part of this, especially airports that are a little underutilized. And somebody mentioned it before on the first panel. How do we do that? Because the airports want the report of what business is going to come into their segment, and the OEMs also need to kind of bring that model together. So we're kind of bridging a little bit of that gap of what this could look like moving forward. And beyond the current airports, there are other sites that we're looking at. We're looking at heliports, obviously not super close because most of those are privately funded, so that leaves a little bit of gap as far as who's going to fund. But we're looking at those type of spaces. And then when you talk about building vertiports, it's very, very critical that we put vertiports, whether it's on an airfield right now, we have airfields that are looking to put a new vertiport on there to be able to take this traffic. But where we put the vertiport is super critical, depending on the airspace and the current use case that we have using our national airspace as it is. So we've been really working hard with a lot of the communities, and again, that's where does that line start between where the infrastructure company lets go and the community part picks up. We're still very foggy there, but building the general infrastructure and again, I'm going to just say that I'm working mostly in the US right now. I'm not really focusing on what's going on. We have some jobs outside the country, but we're not looking at those. We're trying to really figure out in our own backyard how to get this done. Volatus actually has, they're building a vertiport. They have all their paperwork in to put one up in Oshkosh, which is the EAA, which is, they have their big show there every year. And so that's really what we're working with our regulators to really try to erect the vertiport in the right standards, the way it needs to be, to start to use that as a trial base. So we're moving along. We're definitely heading in the right direction. Lots of interest from everyone, whether it's stakeholders that are OEMs or stakeholders that are airport developers. Everybody's interested in doing this, and we're working on a path to get there.
Thanks, Tony. As we think about going from having hundreds of regional or international airports to potentially thousands of vertiports or reused airports, we're also going to have to think about the digital infrastructure. So Don, could you talk to us a little bit about what is it that the country and your company is thinking about the digital infrastructure that will be necessary to enable AAM?
Right. Before I get into the weather part of it, we have to think about what this future looks like. So no pilots on the aircraft, which means you've lost all your heuristics. And no matter what anybody thinks, if you're a pilot and you're flying something 1,000 miles away, you've lost your heuristics. Digital infrastructure is going to be the way we're going to scale the industry. There's going to be automation everywhere. Data is going to be coming in from sources that humans going to be able to track and understand how good the quality is. We have to have a digital infrastructure that's going to meet the future NASA AAM digital flight rules. The digital flight rules, if you look at that, the longest pole in the tent is weather. Because we are manufacturing a perfect system for everything. Remote ID, communications, surveillance, right? Navigation, detect and avoid. And the weather is still 1990s. And if you think that your ASOS is the future of weather, it's not. The future of weather is three-dimensional MRI of the atmosphere. And the reason it has to be that way for this industry is because if you're battery powered, you can't add more gas. You either take off weight, you get someplace slower, and you burn more energy. And if you burn more energy, it means you have to recharge more. And if you don't know what those winds are down to the 1 knot, just like the renewable energy industry, you won't know how long your whole logistics chain breaks down. Because today, like I told you earlier, even crewed aircraft, 30% of the time, it's canceled or delayed due to weather. They could have flown, and that's with the current weather system. The weather system we have is antiquated. It has no new technology roadmap. And the government is not going to be able to do this because of the cost of doing it. So we have to look at this from a public-private partnership perspective. But we also got to throw out all you think you know about weather and think about, because some people will come with evolutionary ideas, but this has to be transformational. And guess what? The technology is available. It's been on the shelf for 10 years. We just got to get the business case and get it out. And that's why I'm working with vertiport designers like Tony and others, because I spent 24 years in the Air Force. I ran global weather operations for airlift. I ran an Air Force base that was a logistics base. I was assigned to technology director at the National Weather Service in charge of the NOAA Observing System Council. I know where all the gaps are. And the problem is we have no data between just above the surface to 5,000 feet. Satellites cannot see through that, below that enough. Weather radar is not the answer. It just tells you where it's raining. It doesn't tell you what the winds are. It doesn't tell you if there's icing in a cloud. It doesn't tell you what the visibility is. It doesn't tell you the cloud heights. Those are the things that are going to really slow down the process here, right? And we have only 2 balloon launches a day of 88 locations around the country to measure the temperature and wind profiles in the atmosphere. And we have aircraft landed airports that only are basically covering 3% of the country. The rest of the country, we have no data. So the models we're using are based on guesses. And guess what? The winds at 300 feet are 50% off on a regular basis. Now, put that in your battery management and tell me how you're going to deal with that, because you're going to have to always be conservative, right? It's safety. If you have to be conservative, you're going to not put all the cargo you can put on that plane. You're not going to carry as many people. You're not going to fly when you can fly. And that's the weather tax, 30% weather tax, depending on where you live. So that's what we're focusing on in infrastructure. We've got to get the right infrastructure at the vertiports. It's not a ASOS. It's 3-dimensional winds in cities, right? We have to measure corridors around the cities. We got to know how those winds are going to blow upstream and downstream. We got to know basically what the icing is, because right now icing is just a forecast and it's always going to ground you. But you can fly about 30% of the time because there's no icing in the cloud. We have to get better measurements of that. We can't just send an aircraft up and say, oh, you hit icing. That's pretty much, 1980s, right? So that's what we're going to be focusing on. And that also has to be tied into a digital infrastructure where all the other data is digital. And that weather data has to be certain enough that you can run actuary and do analytics to plan your fuel, plan who you're going to carry, how fast you're going to carry. And you need to do that with lead time. You need at least 5 hours of lead time. You can't have people showing up at the vertiport and you have to explain to them the winds are stronger than we thought, but it's a beautiful sunny day, but we can't get you to the airport on time. It's just not going to happen. So that's where I'm going to be focusing. And I hope that you guys start thinking of weather differently than you think about it today.
Yeah, thanks. Those are great considerations. Dash, you mentioned that the DoD is acquiring advanced air mobility airframes from Joby and others. From an infrastructure perspective, what is DoD's top of mind for DoD in terms of having the infrastructure to fly those aircraft?
Sure. So the fact is what the commercial infrastructure needs are not exactly what our needs are. Our needs are rapid mobility. We don't need infrastructure that is stationary and can be built over years. We are looking for moving these vehicles. Right now it's for logistics support, but later on it could be for warfighting capabilities and stuff. So we have to get there, drop the aircrafts, put out landing pads or whatever we want to call it right now, vertiports, and then have infrastructure, digital infrastructure to support that. So that's the thing. It's about rapid mobility. So the good thing is that doesn't mean we are not going to be focusing on the commercial infrastructure piece. We're going to be learning from that what is good, what is not. So when it comes to understanding this, so we're setting up proving grounds. So one of our proving grounds is at Eglin Air Force Base. Now, what is proving grounds and what's the difference between a proving grounds and a test site? Test site is working with companies to test integration into the NAS. We are the proving grounds that are looking to validate and verify what the companies are saying, what the companies are providing FAA data is good or not. And this is where we are between the test sites and the NAS integration. What you can do, what challenges you face when you bring new aircrafts into civil airspace, we don't have all those restrictions in military airspace. We can test quicker. We can get you a flight release and get you out to test your system. So this is where our partnerships that we are working with FAA, NASA is to understand where the challenges are and how we can overcome it. So at this, I keep saying this to a lot of folks that FAA is the regulatory body, the decision makers. NASA is the research body. We are the operational risk takers. We come here to help solve the problem so that we can use good technologies for our use cases also. So when we buy these aircrafts, we also have to buy, I would say, the whole kit. That is the landing pads, vertiports, the infrastructure needed to support those things. But this is where the dual airspace needs come. These aircrafts will leave military airspace, go to civil airspace. A basic use case could be even picking up our soldiers or DBs from commercial airports. We can deploy eVTOL, pick them up and bring them back. So now you're transitioning between two different type of infrastructure needs. So at the same time, we also have stationary bases where there will be a lot more operations, could be the maintenance facilities and stuff. But there is a lot of challenges here, which we are seeing, like And when we are talking to different organizations, agencies, state, government agencies, everybody is talking about specific areas. Even companies are talking about specific areas. Just examples like aircraft, the aircraft dimensions play a big role on vertiport designs. Your battery charging times. Every aircraft has different charging times, different charging needs. In addition to that, depending on the propeller configuration, the hovering time also for these aircrafts are different, which creates downwash below. So there are things which I'm not an expert in this space, but I understand a lot of this. And that's why the Airspace Innovation Team has been tasked to see what are these challenges, what can we, like phase one, what does phase one need for us? Is these aircraft should have situational awareness. That is our basic need. That is, if this aircraft takes off or switches on, we should be able to know that it's ours. Second is if it can have separation. For that, we need to also know the weather part of it. So we're working with companies, we're working with agencies to figure out this problem like below 12,000 feet. Our interest is below 12,000 feet because it fits into both SUS as well as eVTOLs. But when it comes to terminal procedures, it goes lower than that. So these are things we can only when we work with agencies, and that's where the partnership piece is key here. States that are looking to put money into building infrastructure need to talk to others in the state as well. There are pilot programs. There's electrification pilot program. DoD has a pilot program where if you're building something close to a base, DoD puts in money because it can help the base as well. And these, I'm not talking about, small pot of money. I'm talking about millions. If you combine these things, you could get something valuable. And that's why for us to set up a vertiport is not going to be difficult. If we know what is needed, we can set up a vertiport soon. But the problem is every person we talk to is focusing on different pieces of it. So it's good to see that traditional, like airports could be the starting points for this. So same way we have bases, we have ATC managing these bases, we can have good situational awareness. And at the end of the day, it's working with the FAA to make sure if there are challenges on their side, how do we overcome those challenges? And I have John Soy on my team who has just come from FAA, and he's been a Eglin ATC chief. So you have a person who understands both the military side as well as the FAA side. And that's why we are really serious about every piece of this.
Thanks, Dash. And just to round out the infrastructure conversation, Congress did authorize $25 million to state, local, and tribal governments in December in the fiscal year 2023 Omnibus Appropriations Bill. That money should be flowing out later this year. So if you are a state, local, or tribal government, or if you are a company that is looking to find your initial launch sites, and want to make sure that infrastructure is ready, these are for planning grants. So it would allow you to do the engineering studies, some consumer or cargo demand studies to make sure that you're prepared as these new advanced air mobility aircraft come online, that you're ready, your community is ready to adopt them. So keep an eye out on that from the FAA and DOT. So we're going to quickly talk about regulatory standards and updates. And Scott, I'm going to start with you. Obviously, these aircraft are going to operate a little bit differently than traditional aircraft, potentially smaller, shorter routes. But what are some of the regulatory and standards that we need to have in place in order for them to launch as designed?
So one of the first things we already talked about here, the infrastructure side. So the FAA put out the EB 105, Engineering Brief 105, and that's sort of the initial strike at what would the infrastructure look like, what's sort of the most conservative, fastest version of putting in place a vertiport that might be able to use existing infrastructure, how does that look by comparison to helicopters, electrification, all that kind of side. And then we also look at the manufacturing side with these aircraft. We're talking about taking a completely novel and new idea in the way of manufacturing that uses newer, space-age, lighter materials to be able to handle the reduction or the requirements on the battery side. So it's chemistry around batteries is a little bit different than aviation fuel and the safety that's required for that. There is also a lot of knowledge in our traditional manufacturing side for vehicles, ground vehicles, cars. You see companies like Stellantis that have partnerships with some of these manufacturers that are working on what are ways that we can get from these sort of ad hoc, one-off, one by one pieces of manufacturing into sort of higher rate manufacturing. And so how does the FAA or how do other people look at that and certify that these companies are going to be able to repeatably and reliably build aircraft that are going to be safe, that are going to be safe for passengers and safe for the airspace. Then there's also looking at pilot requirements. So being able to operate these aircraft is a little bit different. They have different controls. They have different sensors on board than a traditional aircraft. You may have no actual manufacturing, like mechanical feel of what the movements are going to be based on the sticks that you're using. There's also a lot of autonomy systems that are being built into these aircraft. How do we look at the code that runs that autonomy side? What are we comfortable with letting the aircraft essentially decide on? And then also, if we eventually get to that point where we don't have that pilot on board, how do we certify that remote operations sort of operation side, right? What do those communication links look like? What sorts of pieces of information are necessary for us to feel safe that that aircraft is going to be safe and not pose a risk to anyone else that's operating either in the air or on the ground? And so there's a lot of work that's being done and looking at all of these components individually, as well as all of them put together. And then there's also the look at what do we need from a maintenance perspective. So as these aircraft are going through the operation cycle, they will have similar duty cycles to where an aircraft that needs to be overhauled. So what do those things look like? When do propellers need to be changed out? When do you need to cycle batteries out of working use? What is the acceptable level of charge? You have degradation over time, especially if you're charging those batteries quickly, like we're seeing with electric vehicles on the ground. So as we get that technology moving along, how do we build a regulatory structure that moves along with that movement and improvement in technology, while also ensuring that there's safety in the aircraft themselves, in the operators, in the way that these aircraft are then cared for as they're in operation? The other thing that we have to think about is noise. There are a lot of sort of negative connotations around when you look at traditional helicopters being in urban environments, being near residential areas. Same things that if you look at airports, how they're usually not within a residential neighborhood. The noise signature that's provided by these aircraft is significantly different and significantly higher. How do you measure that effectively? How does that affect the environment? And those are sort of kind of high-level looks at what are the kind of regulatory items that we need to think about from a certification standpoint, from an operational standpoint. There are a lot more, but I think that's a good quick overview of it.
Yeah, it's a great overview. And so that's why it's so important to continue to engage with the regulators across the country, and AUVSI and a number of associations in Washington can help be a conduit for you to do that. So make sure to stay engaged with Scott and his team. But the one last thing, and we have 10 minutes left in the session, we're going to come to questions next. So if you have questions, please get them top of mind. But the last thing I wanted to ask was Dawn about standards. So one of the things that FAA and others rely heavily on is for industry to come up with consensus standards so that they can refer to them and through the regulations. Could you talk a little bit about the importance of standards? And specifically, I know ASTM has their F38 standard that they've been developing, but could you break that down a little bit?
Yeah, so ASTM F38 has really taken the lead on standards for UTM, unmanned aerial system traffic management, remote ID, all those areas that we're trying to lay some groundwork that then working with the FAA, we figure out how to then turn those into rules, right? So what you're seeing right now is we're working on the Part 108 BVLOS rule, right? Those standards that were developed by ASTM have helped, laid out the groundwork for what standards will look like in support of that rule. And so whether also, several years ago, I was knocking on the door saying, can we do a weather standard? Everybody told me, no, we don't need a weather standard. We have weather data. And I said, okay, but it's not going to be good enough. And they said, yeah, it is. We're told it's good enough. But I just kept bugging them. So Phil Cano finally let me start a standard group, and we did that. And fortunately, we did that because it's taken us almost 2.5 years to get the weather standard drafted. And it should be out in about two months, month and a half, 2 months. I'm on the phone with the FAA every week. They're helping me with the standard. What we're developing is a different standard for weather. It's going to move away from approved sources being only certified instruments to a data performance standard. The data performance standard will allow for the opening up of data sources outside of just ASOSs. And what it'll do is we'll have a quantification and a verification process that has to be put in place. It won't be the Wild West. We won't allow that. But we will be able to apply metadata to people who hand their data in, have that assessed, sent back out, and then that will be open for use in UTM and other places. So that's what we're working on. It's really important because that's going to close the gaps. If we don't open up the spigot for weather information, we won't be able to close the gaps. And if we wait for the government to close the spigot on weather data, it'll be 2040, 2045. So what we need to do is look at that standard. We're going to start testing it. NASA, we have 3 SBIRs in NASA that we have scanning wind LiDARs and all this advanced technology we talked about. NASA wants us to set up reference networks, figure out how you fly a drone through an area and collect the data off that drone and see how you can validate that data, how good the error rates are, and make that useful data. So you can take data off of drones. We can have data coming off of cameras. We can have, data coming off of a lot of different things that will close these gaps. So that's what the standard is going to allow us to do. And so what the next step is that we're going to be working with the FAA. So if you're out there, if you're getting government money for weather sensors, come see me, because we can work with you to get the FAA to potentially allow us to use you as a test area for this new standard, which means you can get lower cost sensors to fill the same role and unique sensors, and we can then feed that data back to the FAA. That's going to help their risk management framework, and that's going to help lead to an advisory circular in 18 to 24 months. The faster we move on this, the faster you all have relief of getting lower cost sensors, better data, and we make that available through public-private partnerships. We don't have to worry about the funding right now for this. Obviously, there is going to be some cost, but there's always cost. But if you want to get that 30% back, it's probably a good business case.
Yeah, that's exactly right. The standards are so critically important. The panelists are prepared to talk a lot more, but please come visit with us. I want to go to questions throughout the course of the conference, but let's go to questions.
Yeah, I'm George Gray, working with the Terrebonne Airport, which is about 90 miles west of New Orleans. We're the largest heliport in the world. We have over 100 helicopters going out to the rigs. So, two-part question. We do micro weather now out there on the rigs, but what we do is how we fly. So that's one issue. Sensors are a very cost driving factor.
Right.
Infrastructure, we're going to add 5 years now, preparing close to launch unmanned and now AAM. So our 2 biggest operators are bringing in 8 manufacturers of OEM aircraft. 2 of them are Elroy's and Vision Cargo. And through all our studies and stuff, the biggest problem we're finding are local. And that is with your power, put 10 aircraft on the ramp, and you need 34 megawatts of power. You don't bring that in on the line. That's not a very good problem. The next one is the Public Service Commission for every state. They set the law on that commission. And then finally, every state has a fire marshal. You have to deal with the fire marshal with every state. So I'm interested to hear how you've been approaching the state-by-state issue.
So real quick before you answer, just to summarize it for folks that couldn't hear it and for the recording, the question is about local considerations about both weather, infrastructure, and how you work with local authorities to help prepare for the future of AAM infrastructure. I could summarize it that way.
I'm going to add a quick comment here that I'm not sure if everybody's aware, but we do have a new division of the FAA called the Emerging Entrants Division. And that, to me, has been super valuable to have that division actually take specialists throughout different sectors of Office of Airports and other sectors of the FAA, and they put everybody around the same table, whether it's environmental or what have you. So first key is always check with the FAA before you're doing anything. Obviously, you already are. That has that particular division has been a wealth of information for us, and they answer quickly and efficiently, and they want to get done what we want to get done as quickly as possible.
I'll just take the weather piece real quick. So on those rigs, we want a wind scanning LiDAR. You want to see those winds, not just the surface base, because when you start flying unmanned vehicles out there and you're worried about winds and battery, we want to know what you're going a long way, right? So you really want to understand how much wind you're going to have. On land, in terms of the regulatory for us, we're working with Crown Castle Tower, and we're going to hopefully avoid all the weather sensor regulatory problems by putting our sensors on top of their towers. So around your airport, around your vertiport, a hope is that we can really streamline that. And then, of course, you could put what you want on your vertiport. So if you need surface-based observations. But yeah, let's talk more afterwards. I can get you more background on that.
Great. Other questions? Brett?
Question. Over wandering shooting 2,000 yards now, we used to wish that we had a Doppler dart that we could send first to go through all those different ravines where the wind would go this way or that way, but also altitude, the max ordnance that you figure that out as you were going towards the target, how that would be affected up above. So understanding wind obviously is huge and important. Did you say MRI at some point?
Yeah.
Can you tell me about that?
I mean, it costs money, right? I mean, MRI is a lot more expensive than an X-ray, right? So, but you can get wind LiDARs along those routes, and you can see those winds up to 6,000 feet at a very high resolution for a 20-kilometer area. But one of the things we also have is we have an AFWERX project right now at Grand Forks for a Weather Scout drone, which would have on it a radiometer, a infrasound device that can go out and do some scouting ahead of time. That's what I think the future of Air Force weather is. Because I used to be, in the 80s, we used to send a reconnaissance airplane out across the ocean because we didn't have satellite imagery. We're going back to that. And so what I see like in Westpac is having drones that have weather sensors on them that aren't the kind you think today that are collecting this data in real time and connecting it, networking it locally. You got to also think about calm out and losing your data. So you have to build an infrastructure. But yeah, no, I'm serious. It depends on, I believe, we've done the math that having wind scanning LiDARs and MRIs of the winds and all that is affordable when you think about how big this industry is going to get. You amortize that cost over lots of drone operations. And we found a 10-to-1 return on investment for AAM.
So obviously there's a wealth of information up here on the stage. There's also a lot of questions that we didn't get to here. Fortunately, we're here all day. And so I would really encourage this conversation to continue off the stage and in the networking sessions that we have throughout today. Thank you for a fabulous panel with lots of wealth of knowledge, and look forward to chatting with everybody.